leverage shared libraries, config generation, and how that dramatically improves speed, safety, and adoption at Discovery. So she just gave me a quick intro, so I won't spend too much time here, but my name is Garlick. I started at Discovery about 4 years ago, and my title is a lead cloud solutions engineer. I have a focus on cloud and container-based solutions, but overall, anything we can get our hands on, we look to improve. Give you an idea of what we support today. We have many globally distributed teams, and they manage things such as ad sales, content delivery, rights management, general internal IT, broadcast systems, security teams, video on demand, and live streaming. We deploy across both Amazon, GCP, VMware, Terraform and Kubernetes in most cases. And we currently run about 150 services in production, running in numerous languages, but primarily Java, Node.js, Python, and some Go. We also run a number of open source and vendor tools. Relevant to this would be HashiCorp Vault, running Kubernetes itself, Armory or Spinnaker itself. So where we started, when I first started 4 years ago, the developers were looking to shift towards a microservice architecture. But as you can see the list here, we had basically every problem that you could have. Like to set up a new service, it took days, weeks, worst case months is what I saw. Deployments were extremely error prone. They were done on weekends, they required downtime, they required dozens of teams to be involved, DNS teams, somebody running database or database migrations, someone else going grabbing an artifact from Jenkins and throwing it into JBoss or Docker container. The environments were super inconsistent. Like you had no idea what you really ran in your test environment was actually going to work, and a lot of times it didn't. And we had tons of tools, but low adoption rates. Like we had plenty of APM tools, but one guy was using it for managing 60 applications that he managed for developers. We wanted to get a lot more people in there other than our single person. So we had a few goals when we started. We obviously wanted to get away from weeks at a time to get up a new service and to make it very quick. So we were aiming for 10 minutes from someone running a job to a help check pressing in production for that application. We wanted a full, complete configuration for production and all our environments defined in Git. So we were looking just for a simple application with a health check, APM configured, all secret management set up, a full CI/CD pipeline for it, all sorts of networking, ingress, DNS certificates, and so on, and as well as monitoring, logging, metrics, alarms, dashboards. Ideally, we want all those done by default. And then with all that, we were hoping to gain quick, safe, and immutable deployments where the flows through the tools were identical, whether it be Terraform or Kubernetes, the experience would be the same. We want to get the environment consistent, easy to update. And then lastly, we want to get ease of use. And we were aiming in the terms of making it so our EVPs could run this job and set up a new application. And they probably had no idea how to update it after, but they could at least start one. So we initially started with a bunch of building blocks. So we primarily had chosen Terraform and Kubernetes to define all of our service components. So that gives us, everything that's related to this service is going to be defined in Git for us. We use dinghyfiles from Armory and Jenkinsfiles to find and discover those configs and deploy them. Obviously, we want to get as much as possible of the config sorted to get 100% ideally. I'd say we're probably around 95% for a lot of things. And then lastly, once we do all this, we want to make it really easy to update and maintain existing services. So we're able to use reusable code to ease the generation, enforce those standards, and apply those updates. So in this case, that would be a Terraform module, that'd be a Jenkins shared pipeline, that'd be a Dingy template, managed pipeline templates, E2. Obviously, you don't have to use any of the tools we're talking about here as long as they support some form of that, then you're good to go. So now that we have these building blocks in place and we can kind of define all the stuff we want, it's still relatively slow. We're not in the weeks to months range, but we're in the hours to days range. We still have a couple teams that need to be involved to set up the service, and more or less people just end up copy and pasting. It's like, all right, we're setting up a new service, copy and paste these modules, deploy them, And we thought we could do a little bit better than that. So that step was to tie it all together. We have everything to be able to find in Git, so we decided why don't we just generate Git repos when we create a new service. So I just have a really small flow here. Starts off by a user, could be a developer, I said, could be a VP. We've had VPs run it to test it out. They run a job on Jenkins, which generates a couple Git repos on our GitHub. Those have Jenkinsfiles and dinghyfiles in the repos, so you can see here, one for the service, one for the manifest, one for Terraform. Those all predefined, just what we said before. Number of times, devs put else all the time for new apps, they don't have health checks, so we put health checks automatically in place. They come to us and they're like, well, all our secrets are just checked into Git in plain text. We already have vault in place so that we can get them to put them in there. We have our Kubernetes manifests, we have our Terraform stuff. So the Kubernetes manifests are just what we mentioned before. It defines our ingress, it defines either public-private certificate, defines network policies, it defines anything that Kubernetes can manage. So once they kick that off and those repos are created, they automatically get picked up by Jenkins or Spinnaker, or Armory in this case with the dinghyfiles. So you can see here, those get picked up and they automatically go through our build pipeline, which is kind of simplified here in just the form of Jenkins pushing to JFrog, or potentially a Git webhook going to Spinnaker, or even Jenkins just firing a webhook at Spinnaker. So you can see for our services, Jenkins builds those, publishes the candidate JFrog. For our Kubernetes manifest, Jenkins also builds, validates some stuff over those, which eventually triggers Spinnaker with a webhook. And then for Terraform, we're just using Git webhooks there. So at that point, everything's in Spinnaker. Your devs don't really need to care about the center piece here. They care about living in GitHub, and they care about living in Spinnaker itself. And you can see the actual deployment now, basically taking two paths, whether it's a Kubernetes managed piece of the service or a Terraform piece of the service. And you can see there on the side, every image there is something we either use currently, or no, everything is stuff we use currently deployed by either Kubernetes or Terraform. So, and if you can't find a Terraform provider to support a tool you're using, they're not that difficult to write, and there's plenty of documentation around that. So what next? We've improved a lot of things, but we're still extremely immature. Like, we started from the worst possible case, and now we're into a case where we finally can actually start doing interesting things. So we do have a snowball effect. Now that things can happen extremely quickly, we can continue to build out modules, libraries, take advantage of new features as developers want to use canary analysis, and we'll already have all the metrics in place and so on, so we can get those in easily. And when we update that, it'll apply across all our applications. We want more initial config options. Like I said, we're in a very minimal state of, do you have a health check? Do you have config? Do you have Reusable shutdown? But we can go even further and say, all right, well, you want a Postgres database? All right, we'll spawn that, automatically store that configuration in Vault, and your app already have pre-configured to pick that up. We're looking at ephemeral test environments. So because everything is in Terraform and everything is in Kubernetes, we can easily make a pipeline that a developer can trigger to run all these templates, execute some tests, and then tear it all back down. And lastly, we kind of tricked all the devs into adopting our stuff here. We put everything in place so they didn't have to know anything at all initially, which was really the biggest barrier. Like, we have tons of tools. Like, we use New Relic, and we use Splunk, and we use more than I can name here in like the little bit of time that I have. But yeah, we need to train them better on them because we need to be able to have them update those and really use them. So that is it, and thank you.